So one of our greatest strengths that we had in designing our drone was that we went with a hydraulic propulsion system. And our hydraulic propulsion system enabled us to move away from electronic motors and enabled us to move away from the gear train of the Screw drone last year. And it gave us a simplistic control, and it gave us water resistance, and it gave us a lot of torque for what we're actually getting out of the motor. So in addition to that, everybody in the coming years will be able to have our tank, they will get our pump, our solenoid valves here, although those might want to be changed in the future to open center valves so that when you cut off power to the solenoid, it doesn't immediately stop and freeze up the lines to the motor. You would also get these hydraulic motors and the motor mounts that are already fabricated.
So the motor mount design worked out really well because the design allowed the motors to have a little bit of slop if the shaft wasn't perfectly straight coming out of the pontoon, but it would stay oriented straight up and down so that it wouldn't just spin freely on the pontoon. We also made the design so that when we transported it and we put the motors on and off, we could just slide them in, and then they were held in place by placing a bolt right through this little hole here. We welded them together so they wouldn't slide back out. So that was a really nice mount design that we came up with, and definitely a good one to keep for the future. You'll also notice for all the other mounts, whether they be for the solenoids, for the engine, for the tank, everything is drilled through on separate pieces of steel as opposed to the tubing, because it's very difficult to get good straight holes through the tubing. So that's another good suggestion. It was a really good idea to use steel for the pontoons as opposed to aluminum like last year's group. That being, although they have more weight, they have more strength overall, and the ease of fabrication with steel is much better than with aluminum. Some important aspects of the pontoons that could definitely be changed for the future are the biggest aspect being the helix angle, which is measured from perpendicular to the pontoon up to the tread. So it's this little angle in here. We made that 25 degrees, but you can kind of play with that in certain calculations. You can also change the overall diameter of the pontoons, the length of the pontoons. We'd suggest maybe going to half this length, where at 4 feet you could go down to 2 feet. You could also decrease the diameter from a foot to about 8 inches. And then the other big thing that we had for an obstacle was all of these grousers, although providing great traction, ended up bogging the machine down when it became stuck in certain conditions. So if you could use round stop, for example, that would allow, although a little bit of slippage, the ability for the drone to slip and then eventually continue through without totally stalling out and not being able to move.
So one of the most important parts of figuring out the total geometry of the drone was to figure out the torque requirements. So once we figured out the geometry of the screws, we checked using some simple kinematics to figure out the torque required to move the drone over a certain distance. And then that led us to figuring out what size type of motor we would need, and from there figure out the pump and the tank size we need, the type of flow rates we need. And what we would suggest is for next year to do a more in-depth kinematic analysis, including for different surfaces such as mud and snow. So one of our suggestions for proper flow control would be to purchase a variable flow controller. It'd be a little bit more expensive, but having the tank, pump, and motors will make it a lot cheaper. And that would allow the 2 solenoid valves to be in parallel versus series, and would allow for better control of how much flow is going to each motor and each pontoon. Would make turning a lot easier and moving in certain surfaces a lot easier. And then we would also suggest using a stronger chain, such as 50 or 60 chain, probably 60 chain at the minimum. And the variable flow controller would allow us to, or allow you to do away with this clutch, which caused us a lot of problems during testing.
So our final, and in a way our largest obstacle, was the weight of our drone. It weighs 410 pounds, which is 210 pounds over the limit. And in order to fully operate to accomplish the goals of Capstone, and also to operate the way we want it to, cutting down on weight by going with, say, an aluminum frame, but keeping, the square tubing so it's really easy to fabricate, keeping the steel on the screws but reducing their size to 2 feet or so and reducing their diameter, perhaps going with round stock, would enable you to get a greater amount of torque out of these motors and be able to operate better on different terrains, which was a huge obstacle we had, as well as if you still want to go with this sort of grouser design, going with a shorter grouser that doesn't dig too much into the mud would help. And the output of this hydraulic system as it is now would be greatly improved with a lighter drone and better screws.